Hello everybody, hope you've had an amazing weekend so far. It is your boy Trix, and today we're going to be doing some more Toy Robot in Elixir. So if I cd into Toy Robot, there we are. Load Toy Robot robot.exe. So right now, if I run a mix test, we should see that everything passes, and we left off where we have movement in all directions. So if I just open up the book on my phone again, just like last stream, I'm going to be reading it off of my phone. Apologies that I am not able to share the actual screen of the book with you, as it is a paid book. If you would like to see the contents of the book and not just me coding it, please buy the book. Other than that, I do have the book up on this screen, and I do have the book linked into the description. I do not get any what's the word? There's no endorsement or like any financial incentive for me to promote this book. I'm just using this book to learn Elixir. Like I like BDD and TDD and currently DDD projects, and I think they're pretty cool. I found this. If it's not a good book or not a good series, then by the end of this series I will give my thoughts on it. So far I pretty much like the book and how things are going. There's some things that I think do make sense, some things that I think don't make sense, but it's not about the style of the book, it's just about the style of how they've coded it. Like when they have like north or east, south and west, you could just name that as X and Y positions, but in the book, in the code, they actually name them north and east, as you're moving north in a positive direction and north in a negative direction, and then east in a positive direction and then east in a negative direction, which just makes sense if you just write X for horizontal and Y for vertical direction. Don't know why they've done that, but I've changed it in my side. Other than that, I like the prose that the author's speaking in. I like the way the book's laid out so far. I've only gotten through 15 pages so far, so we'll see how things go as we get along. I'm going to be honest in my review of this series, as I was with PNG Me, where I was like, oh, I don't know why this is like this. Oh, we could do it like this, and I done some stuff where some tests that I tried doing, I kept failing, and I had to look at someone else's solution, stuff like that. You'll see it on stream. I'll try not to do this off of stream, but these are just I'm just doing like a whole disclaimer thing because I didn't do this for PNG Me, because PNG Me was just open source. You didn't have to pay for it. This is a paid for book, so please, if you do want to use this book, support the author. Again, this is not any like affiliate scheme or whatever. I don't get any money from doing this. This is just me saying, if you want to check out this book after my series and you want to implement it yourself, check out the book. I'll also have this project up on my GitHub. I've already got it on my GitHub, so if you want to check out my code for how I built this book, you can. I do recommend building it yourself so you can learn Elixir yourself by doing and using this book. But other than that, let's get right into coding. Also, again, if the author does come across this series that I've made and there are any issues with me doing it in this style, me coding it on stream or whatever, please reach out. I am glad to take down these videos these streams, if you feel that it's not representing your work in the right light or whatever. I don't want to step on anybody's toes or anything. It's just I thought this project's really cool and I wanted to work on it. With that out of the way, for people that watch this in the future, I'm probably going to do this disclaimer on every video I make for this, just because it's a paid product. I know it sucks, but it's just because it's a paid product, and there's nothing about it in the description of this that I am allowed to do this. So I'm going to edge on the side of caution and just say, hey, if this isn't cool, I completely understand. I'll gladly take these down if you think that this isn't okay to do. But I really wanted to go through this book on stream. I'm not going to obviously show the contents of the book, just me coding the book out. I hope that's okay. If not, fair enough. I'll take down the live streams, but I'm hoping that me keeping it on my GitHub is still okay. Thank you. Anyway, let's get into reading. As before, I'm going to be reading the book from my phone. you'll only be able to see me coding and the actual page to buy the book from on screen. Cool. I really like doc test so far. You don't really have that in other languages. Well, the languages that I've used, you only have like JUnit in Java, and in Rust it doesn't really count as a doc test, even though they're in the same file. I don't like that. That's how Rust does it by default. But Okay, so what I've read so far is, which makes sense, that what we've got in here does work, but it only works because the struct or class that we made for it is unique to each test. So we're not using like a normal class where you will have like the actual class and then the positions that you want to modify, and then have like getters and setters for those positions. What we've done is we've just made like an anonymous class and said this is what the class will look like. These are the fields on there, and this is what happens when you do this method. So if you were to change move underscore east on line 2 and 4 to move north, it would fail, because on line 8 we're trying to modify move east for that X position, but move north is not defined for that. So when you try to modify that and expect an outcome to happen, it will fail because move north is not present as a definition for that test, because that modifies the Y position, and the Y position is not present on that struct or that class. I'm just going to drink some water. Also, apologies for any background noise you hear of like kids like screaming or whatever. Someone's playing in their garden, and I don't control my neighbors, obviously. There we go. Okay, so now we are going to be implementing like turning mechanics. So like if you're facing north and you turn right, I said turn right and I moved my hand left. Sorry, if you're facing north and you turn right, you'll be facing east. If you facing north and turn left, you'll be facing west. Interesting. Okay. So what they've got here is, if I just jump to 9 and then let's jump 16 up, yank, and then print, whoops, undo, print, whoops. How am I gonna do this? There? That should be okay. There we go. And then moves the robot one space in the direction it is facing. So this currently has Y. Change word Y, right? And then it has facing, which is north, right? Then just change this to Y, and then this is facing north. Then when we move, we're going to change this to Y is 1. That's what that does. And then over here, what this does is, oh whoops, yep, and then this line is removed. So you have your Y position and you're facing north. If your Y is 0, you're facing north, obviously that's the thing you're setting on. And then if you move, you should increment in that, right? In whatever direction you're facing. Cool. So what it does now is, so okay, the way to explain this is going to be different to how Java does it, because the way that Java does it is when you run like JUnit tests, your JUnit test can run in any order that is picked up when you do reflection on the class, right? So the way that it works is in Java, you have an annotation for a test and you use reflection to grab all of the methods that have that annotation on it to then execute that method, right? So because they're strings, most of the time they'll be string matched and just get loaded by the JVM or whatever at compile time based on those string matches, right? So they should be in order. You don't know what ordering that the JVM will load that in, so it could be in any order as long as it's just present, right? So you could have tests run out of order. You could have tests run in parallel, sequentially, stuff like that. Single-threaded, multi-threaded, whatever. Just however your tests are made. Apparently, with Elixir, from what this book says, it runs sequentially from the test at the very start to all the tests below it. So when you run mixed test, it will fail at the first test because of the first test that gets loaded. So yeah, this says left is nil, right is north 1. We've just changed it to Y1. Oh, cool. I've never seen that before. So the way that this does it is in the toy robot in here. So this does comma do robot. Oh, whoops. Move north. Does that work? I might have written that wrong. No, that works. That's sick. So that's just a one-line function. That's cool. So you don't have to specify that the whole def like definition like this, where you have def, do, end. If it's on the same line and you have a comma, you can just do def function name, comma, do function body. That's pretty cool. It's kind of like a lambda, where you have, here's the thing that you want to do in brackets, then a function pointer to the thing that it should do as like the return or whatever. So this is just saying your function pointer is no, your, what's it called? You have a you have an argument to a function point with a function pointer to do something, right? So your argument is robot, your function pointer is do, and your method to execute is robot to move north. Well, really, your do robot to move north is a function pointer, right? Because everything's just a function in Elixir anyway. But that's pretty cool. Okay, cool. So this is actually writing the tests for this inside of here. So you've got doc test, then it aliases toy robot dot robot. Then we've got describe when robot is facing north do. Do and end, setup, do, and this is ooh, e. Okay. I'm gonna write this out, but I don't like that syntax. So you got an optional for OK, then you've got a struct of the robot to a inner struct of the Y position at 0 and facing being north. And then 3 at the end, yeah. Then it does test. It moves 1 space north with the robot struct. Robot do. Then we've got robot equals robot. Whoops. Robot.move. Then we've got assert robot north y equals 1. Sorry about the north bit. It's got the variables as north and east. I've made them y and x. Then it's got the other one. So let me just grab this. 0 yank print. Whoops. There we go. Whoops. Equality. That's what I need. Not equals. Don't need reassignment. Okay, so this fails interestingly. So when you run a mixed test, cool. So test when robot is facing east, it moves one space east. Facing east, X 0. Key Y not found in it. Y not found in. Yeah. Ooh, that's cool. So, oh, so I was thinking about it all wrong. Okay, so this isn't a struct from what I thought it was a struct. It's just a map with a percentage there to symbolize, I don't know what that percentage is for actually. That you can modify, maybe that it's mutable. But the way that it does it in here is you got your def module for toy robot, then you do def damn def struct, and then you've got y0 x 0 facing north, and that's how that does that. Ooh, that's pretty cool. So the way that it does it in Move Robot now is it's got this doc test is still the same, but this does percentage underscore module underscore. I think that's one underscore. No, that's two underscores. Percentage underscore module two. Whoops. Robot. That's what that does. Oh, that's cool. So in here, how does it do that? Cool. So, okay, so it does like that, and then does the same thing basically everywhere else. Interesting. Okay, so then in move east it does the same thing, but it does that. Yeah. There we go. Toy robot. What did it change? I'm a bit confused. So we're done. Oh, was I supposed to make this alias after doing the doc change? That might make more sense now. Okay. Yeah, because it looks exactly the same as what I've got right now. Cool. So, if I... They should all pretty much fail. That's not what I was expecting. Oh. So doc tests are passing, tests are still failing. Okay. Okay. So it does That alias is still there, that's present, and we've got cool. Ooh, that's cool. So you can do, well, it's not cool, it's like method overriding kind of. So you can do, then all you need to do is east. What is it? It's percentage robot facing north equals robot. There we go. Cool, so now it's going to do east and west. I mean south and west, sorry. South. When facing south, move south. Facing west, moves west. -1, south, west. Yep, that looks fine to me. So that should fail. There we are. This is the way I think you would solve it initially, but I'm guessing there's a way to like maybe use pattern matching to move to the right function in just one instead of multiple. Cool. So just for context, this does work. Because if I run it, for test passing. But we can make this better. So this, we are def move with a robot facing equals robot do end, right? case facing due north. Oh, cool. So north is robot, move north. East is robot, move east. South is robot, move south. And west is robot, move west. There we go. So let me just see there's no commas. Yep. There we are. Oh, okay. So this is saying to that it would probably make more sense to make the actual like move operations private instead of public. So to reduce this to a reduce all the other ones to private methods, right? So the way it does that is so not that hard to do. Okay, so it does percentage module and so on. There we are. Then it just removes these dot tests because you can't test a private function. Def p p p def p. Cool. So because all of those dot tests are now just replicated in our normal tests, when we do mixed test, we'll see 1 dot test passes and 4 dot tests pass. I mean 1 dot test pass and 4 actual tests pass. That's pretty cool. So now we've basically implemented the move command. We've got place, which is we'll put the toy robot on the table in whatever XY position and facing whatever direction. Left and right to rotate the robot 90 degrees to a specific direction without changing their position on the board. And then report, which just tells you the X and Y position they're at and the direction they're facing. That's all the commands we have left. Cool, we're gonna start working on turning left. I wonder. I think it's immutable, so it won't change anything. Yeah, it won't change anything. There we go. Yeah, that makes sense. So this is saying whenever you have public and private functions, it's always a good idea to put your public functions all together in order, then your private functions together in order, which makes sense. You make your first public function, then your other public functions, then all of the private function your first function calls you have in order, then your second function in order, third in order down. So you always have public functions first, then all of the private functions being used in order going down. Let me just yank this. There we go. So what it's got now is turns the robot left. Then we got a dot test with facing because we don't care about this y coordinate. Then we've got turn left, which changes facing to west. There we go. There we go. So the authors just said the simplest way to get this to pass is literally just in that turn left method. You just say percentage robot facing colon west for it. But if you continue turning left, you're going to turn south. You're going to be facing south, and that will fail. Turn left to face west. Oh, cool. Ooh, so you could have test groups. So this is one test, right? It moves one space north, test, it turns left to face west. And then, let's say for example in this one, we do something similar. Test, it moves, it turns left to face north, right? There we go. There we go. Oh, that's so easy. Okay, so the way that they're doing it in here, I thought we were going to use like a map or something to check the position in the, or in the, not a map, a list, to like check the position that you're currently facing, then just like increment or decrement based on that. But no, they're just making it a lot easier. You literally just grab your case, right? You grab your case, chuck it in here, right? Because you're facing a direction. If you're facing whatever direction, you literally just have, yeah, it's literally the same. It's literally just, okay, you're facing that way, then robot facing, if you turn left from north, now you're facing west. That's pretty cool. here. Oh. Mm-hmm. Oh. Actually, why are these failing? East and south are failing. In here. Oh. Cool. Okay, so right now is going to do turn the robot right? So the way that they do it in here is you yank, you print, right, facing north, you turn right, you're now facing east. There we go. And I forgot to update these. Turns right. Turns right. Cool. Turn right, turn right, turn left, turn left. Right, right, left, left. Left, left, right, right. Left, left, right, right. Cool. There we go. So now the robot is able to move, turn left and turn right. Now it's going on to like catching bugs. But we are on page 36. I know I'm a slow reader, very sorry guys, but I think this is chapter 2. So I might park it here. We have been going for around an hour. So let's park it here. So there we go. I'm gonna call it a day for now. Thanks for watching. I like the way the book's laid out so far. Like, subscribe, enjoy the rest of your day, and peace.